for your group quiz, to figure out number one, to figure out the common ratio, you need to figure out what would you multiply by on the top and on the bottom to get from 1 to 2. You would multiply by 2. What would you multiply in the denominator by? 5. You know that this is a geometric sequence because it says ratio. Ratio means that you would have to multiply. So the common ratio would be 2 over 5. What is the common difference? For this one, there is a typo, so that should actually be negative 11 on the last term. You always figure out what would you have to add to get from negative 2 to negative 5 to negative 8 to negative 11. You would have to add a negative 3. So remember, common difference can be positive or negative. For the next one, what type of sequence or series does this represent? Okay, this would represent anytime it has a sum, that means you're adding things together. So automatically, it cannot be a sequence. It has to be a series. So if we look at this, this looks like the equation of an arithmetic sequence. Okay, so since this is an arithmetic sequence next to a sum, this would make this an arithmetic series. Arithmetic series. That is the only way that works. Okay, it's an arithmetic series. For number 4, what type of sequence does the following represent? So these are all sequences. To get from 2 to negative 6, if it had a common difference, you would be adding a negative 8. To get from negative 6 to 18, it does not have a common difference of negative 8. Therefore, we know that this is not arithmetic. Okay, we've canceled out arithmetic. Now we want to see if it's geometric. To get from 2 to negative 6, you would multiply by negative 3. You can also multiply by negative 3 to get from negative 6 to 18. Therefore, this is geometric. Okay, it does have a common ratio. For B, to get from 1 to 2, you would add 1. To get from 2 to 6, you would add 4. Then, so this is obviously not going to be arithmetic. It does not have a common difference. Geometric, you would multiply by 2, then multiply by 3, then multiply by 4. Therefore, it is also not geometric. So it is neither. Okay? It's another kind of sequence that you might deal with in advanced math or calculus, but we are not going to have to deal with them here. Okay? This is actually, it's an exponential sequence, and you are not going to deal with those here. For C, find the common difference. Common difference here is add 3, and it works throughout the sequence. Therefore, this is arithmetic. For number 5, insert 3 arithmetic means between 14 and 46. So that means 14, 3 spaces, and then to 46. So if we label these, this is your A1. We are finding A2, A3, A4, and we know A5. Arithmetic means, but in a sequence, we need to use the arithmetic sequence formula. So we're going to find our A sub n is 46 equals A1 is 14. We do not know the common difference. That's what we're trying to find. Your n is 5 minus 1. So 46 equals 14 plus 4d. We know that because 5 minus 1 equals a 4. Subtract 32 equals 4d. Therefore, your common difference is equal to 8. So to get from one term to the next, you have to add 8. If you fill these in, my next term is going to be 22, then 30, 38, and then you can check this, and yes, it would equal 46. So 22, 30, and 38 are actually your answers. For number 6, insert one geometric mean between root 2 and root 50. Geometric, so obviously we're going to have to use the geometric sequence formula. Label these. This is A1, A2, and A3. You label these and plug them in correctly. Root 50 equals root 2 times, we do not know the ratio, and this is going to be to the 3 minus 1 power. That's going to end up becoming the second power. To get rid of the root 2, you have to divide it away. When you divide that, root 50 divided by root 2 is root 25, and that's equal to r squared. Therefore, 5 equals r squared. That's still r squared. It's not r by itself. So take the square root of that to get rid of the square. Root 5 is your common ratio. The ratio means you're going to multiply. So if we multiply by root 5, your actual next term is root 10. Okay, so the one geometric mean in between is root 10. Okay, you can check this. If you multiplied this by root 10 by root 5, you would also get to root 50. So that does work that way as well. You can always check your answers. Write a formula for the nth term. Okay, first determine if this is arithmetic or geometric. There is no common difference. Hopefully you can see that. So to get from 3 to 3, we would multiply by 1 over. To get from 2 to 4, you'd multiply by 2. So the ratio is 1/2. We are writing, since there's no plus signs in between, it's a sequence. So this is a geometric sequence formula. So if you plug into an equals a1 times r to the n minus 1, an, by the way, you have to write the an. If you just write the right half, it's not going to work. A1 is 3. Ratio is 1/2 to the n minus 1. That's your actual answer that we are looking for. Okay, we are looking for the answer there, or the actual answer is the formula. Okay, I'm not looking for you to find any term. Number 8, write the formula again for the nth term. This does have a common difference. Common difference is equal to 4. You're adding 4. So arithmetic sequence formula is an equals a1 plus d times n minus 1. Plug in what you know. So an equals a1 is 1. Common difference is 4 times n minus 1. You cannot leave things like this. They do need to be simplified. So 1 plus 4n minus 4 simplifies to be an equals 4n minus 3. Okay, it does need to be simplified. For number 9, how many terms are there in the expansion? Remember, all we do is take the top number minus the bottom number and add 1. These cancel each other out, so there's 27 terms in the expansion. What are the 3 geometric means between 5 and 80? So 5, 3 spaces to get to 80. If you label these, this is your A1, A2, 3, A4, and A5. We're going to use the geometric sequence formula. So an equals A1 times r to the n minus 1. Your A1 is 5. We need to find the ratio, and we're using 80. So this is 5 minus 1. This would be equal to 80. So if you work that out, divide both sides by 5, we get 16 equals r to the 4th. If you take the 4th root, what number to the 4th power equals 16? R has to equal 2, so that means you're multiplying each term by 2. 5 times 2 gives you 10, times 2 is 20, times 2 is 40, and you can check, times 2 gives you 80. So we're making a list here, so 10, 20, and 40. This is an exact question that came straight from your homework. Okay, you've seen that exact question before. Number 11, what's the 12th term? So first you have to determine if this is arithmetic or geometric. This is geometric because it does not have a common difference. The common ratio is -4. So to get from 1 to -4, you would have to multiply by -4. So this is geometric. So we want to find a sub n equals your a1 times r to the n minus 1. We want to find a12. So we're going to plug in. A1 is 1. Ratio is -4 to the 12 minus 1. So 1 times -4 to the 11th power. If you plug in -4 to the 11th on your calculator, you're going to get -4194304. That's why you're allowed to use calculators on this, because it is a large, large number. Again, what's the 42nd term of 8, 6, and 4, and so on? This one, you should be able to determine that this is an arithmetic sequence. It has a common difference of -2. So we're going to plug into AN equals A1 plus D times N minus 1. We want to find the 42nd term. So A42 equals A1 is 8 plus common difference is -2 times N minus 1. Excuse me, we're finding, so your N is 42 minus 1. So 8 plus -2 times 41, that's going to give us 8 minus 82. If you work that out, -74 is your term. -74. Number 13, find the position of 222 in this sequence. So I want to know where in this sequence would you find 222. So this is your A1. This is our AN, okay? To get from A1 to A2, you add 5. So this has a common difference of 5, okay? It's not multiplying. This is definitely arithmetic. So AN equals A1 plus D times N minus 1, and we're finding the N. We're finding the position, so the term number. So if you plug in 222 equals your A1 is 2 plus a common difference of 5 times N minus 1. You should be able to solve from there. So that gives us 222 equals 2 plus 5N minus 5. Keep working this out. 222 is going to equal, sorry, I just lost my place, equals -3N, excuse me, -3 plus 5N. Add the 3 to the other side. 225 equals 5N. And if you divide both sides by 5, you're going to get 45 equals N. That is its term position number. So this would be the 45th term. Okay, you could either say it's the 45th term or it's in the 45th position. Okay, either way is totally fine. Number 14, rewrite using sigma notation. Okay, so we want to figure out, this is obviously a sum. Okay, sigma notation means we're going to use a sum. Okay, so you're going to see this in your answer. You're always starting with N equals 1 because that's the number that you're plugging in first. So we need to figure out how many terms there are and what's the formula that you're plugging into. So here you can tell that your common difference is equal to 5. If you work this out, we're going to use AN equals A1 plus D times N minus 1. Okay, so first thing we want to do is let's find our formula. So AN equals A1 is 4 plus common difference is 5 times N minus 1. So work this out, we get 4 plus 5N minus 5, giving us a formula of 5N minus 1. So you're going to be plugging into 5N minus 1. We need to know how many times you have to plug that into, so we need to find the term position of 124. So 124 equals, your A1 is still 4, plus 5 is your common difference, and then we need to find the term number, so N minus 1, so you're going to solve there. 124 equals 4 plus 5N minus 5. Work this out, we get 124 equals -1 plus 5N. Add 1 to both sides, 125 equals 5N. If you divide through, we got 25 equals N. So your last term number is when you plug in 25, so you put the 25 on top of the sigma. You will have to do that, so you have to find out the formula and what term number that is. Okay, for 15, find the sum of 3 plus 6 plus 9 all the way up to 300. This is an arithmetic series. Okay, it's a series because they're adding. This is arithmetic because you have a common difference. So common difference is 3. So we're going to use sum of an arithmetic series equals N times A1 plus AN over 2. So that's going to give you N. Do we know what this last term number is? You do not, so you need to solve for that. So AN equals A1 plus D times N minus 1. We're going to plug in what we do know. 300 is your last term. A1 is 3. Common difference is also 3. Multiplied by N minus 1. That's what we're solving for, is the N there. So 300 equals 3 plus 3n minus 3. Positive 3, negative 3 are going to cancel each other away. 300 equals 3n. If you divide through, 100 equals n. So that's your total number of terms. Therefore, the 100 goes in here. So sum of the series is equal to 100 times your first number is 3, last number is 300, divided by 2. These reduce to leave you a 50. 50 times 303. Multiply those together and you should get 15,150. 15,150. Okay, moving on to the last page. Number 16, find the sum of 2 plus negative 1 plus 1/2 plus negative 1/4. And it keeps going. Therefore, this has to be an infinite series. So first thing you want to do is check the ratio. To get the ratio, we always find one term divided by the one in front of it. So the ratio would be negative 1 over 2. That does work because remember our ratio has to be between positive 1 and negative 1. This does work, so we're going to use sum of the infinite series is equal to a1 over 1 minus r. Your a1 is 2 divided by 1 minus negative 1/2. Negative 1/2 turns to positive, so this is 2 divided by 3 over 2. 2 divided by 3 over 2 is equivalent to 2 times 2 over 3. If you multiply that together, it gives us 4 over 3. Leave it like that as long as it's reduced, which this is. I want you to leave your answers like that. You do not need to worry about changing them to mixed numbers. You do not want mixed numbers as answers. It's going to mess you up. That's the sum, right? If you add up all these things together, you'd get 4 over 3. It's the sum. So for 17, Stanley spent 8 minutes cleaning out his closet on the first day of vacation. For each of the next 7 days, he spent 5 more minutes than he had the day before. Including the first day of vacation, how many total minutes did Stanley spend cleaning out his closet? So we're going to find the sum of something. Okay, so we're going to be finding S sub n. Okay, he added 5 more minutes every single day, so this is going to be an arithmetic series. Right, arithmetic series is n times a1 plus an divided by 2. Okay, a1 plus an divided by 2. So your total n, okay, the total number of days he did this was 8. Okay, first day and then the next 7 days. So total number of terms is 8. First day was 8 minutes, plus we need to find what the last day was. Okay, we do not know that yet. To find the last day, you're going to use arithmetic sequence. So an plus, or excuse me, equals a1 plus d times n minus 1. We need to find a sub 8. That's equal to your a1 was 8. Common difference, he spent 5 more minutes, multiplied by, this is going to be 8 minus 1. So 8 plus 5 times 7, that's 8 plus 35. So that means he spent 43 minutes on the last day, so that's where you plug in your 43. These reduce to give you a 4, so it's going to be 4 times 51. If you multiply that together, 204 total minutes. It's all just using those same formulas that you've been given. Number 18, we're almost done. Find the sum of between n is 1 and 50 of just the term n. So that's just basically 1 plus plug in 2 plus 3, and it keeps going all the way until we get to 50. So this is again another sum. So S sub n equals n times a1 plus an, which is your last term, divided by 2. You know that there's a total number of 50 terms. Okay, you should know that because if you count from 1 to 50, there's 50. Times 1 plus 50 is your last term, divided by 2. These will cross cancel, or reduce, excuse me. So 25 multiplied by 51, you multiply that together, 1275. Simple multiplying it together.
We're going to take these home still, right?
For number 19, write in sigma notation. Okay, so that means sum of, because these are adding together. So First thing you need to figure out is if this is arithmetic or geometric. These do have a common difference. You would add 2 to get to each space or to each term. So these do have a common difference. So difference is 2. That makes it arithmetic. Okay, so we want to figure out what is this term number. So if we well, 2 different things we need to figure out. First off, what is this term number? So an equals a1 plus d times n minus 1. 23 is a1, which is -3, common difference of 2 times n minus 1. 23 equals -3 plus 2n minus 2. That gives us 23 equals -5 plus 2n. We add the 5 to both sides. That's going to give us 28 equals 2n divided by 2. N is 14, so that means this is your 14th term. To find the sum, okay, we know we're going to have to write it in sigma notation. You always start with n equals 1. We know that the last number you'd plug in is 14 to get to that. Then we need to find our formula. So write the rule for an arithmetic sequence. So an equals, your a1 was -3 times, well actually we already have it right here. Okay, so you could do that again, or we already have it. You can write it either as -5 plus 2n or 2n minus 5. Either way is fine. I'd prefer if you wrote the variable first, though. Okay, number 20. What is the sum of the infinite geometric series in which a1 is 8 and r is 1/2? Remember, r has to be between -1 and +1, so this works. Sum of an infinite series is equal to a1 over 1 minus r. Your a1 is 8 divided by 1 minus 1/2. So it's going to give us 8 divided by 1/2, which becomes 8 times 2 over 1. Multiply that together, and we should get 16. That one should be fairly simple. Okay, given an arithmetic sequence in which a6 is 39 and a14 is 79, find d, the rule, and a1. So you're going to have to find all of those different parts. Stop it. So set up a systems of equations in an equals a1 plus d times n minus 1. You're going to set it up for both of these parts. Okay, so 39 equals a1 plus d times your n here is 6. So 39 equals a1 plus 5d. Your other equation is 79 equals a1 plus d times 14 minus 1. So 79 equals a1 plus 13d. Line these up. 39 equals a1 plus 5d. Make one of them negative. I'm going to make the smaller one negative. If you cancel these, this gives you 40 equals, this goes away, 8d. Divide through, 5 equals d. Make sure on your test that you're answering the correct question in the correct line, because some of these might be mixed up. Okay, we found d first, which does happen to be the first question, but it's not always going to be. Okay, so d is 5. We also need to find an and a1. So the other way we're going to do this is we found our d. Let's plug in, oh, well, first we have to find our a1. So if you plug in d, okay, let's plug in here. We've got 39 equals a1 plus 5 times our d is 5. Multiply that together, we get 39 equals a1 plus 25. Subtract 25, 14 equals your a1. So here, a1 is 14. That's actually the third thing that you're being asked, so make sure that you are putting it on the right line. And then finally, to write the rule, an equals a1 is 14, common difference is 5, times n minus 1, and then just simplify. 14 plus 5n minus 5, that simplifies to be an equals 5n plus 9. And when you're writing a rule, you do have to write an equals. Okay, if you just write the 5n plus 9, I'm going to take off a couple points because you're not actually writing the full rule. Last one, write this as a fraction. Okay, so the repeating decimals, there's 2 of them. Since there's 2 of them, you're going to write x equals 0.12 repeating. 2 repeating decimals, so we're going to multiply by 100. So 100x equals 12.12 repeat. Underneath that, we write x equals 0.12 repeat. If you subtract those from one another, 99x equals 12. Solve, x would equal 12 over 99, and that can be reduced by 3 each to give you 4 over 33. That is most of your test, okay? These are all the concepts that are on there. Okay, there will be some extra credit, but other than that, that is every single concept that is on your test. And we are taking this test on block day.